There's a dwarf planet more than 4 billion miles from the sun that's leaking a gas it should not have. Not water vapor, not nitrogen, methane, a gas that should be frozen solid at nearly 400 degrees below zero. But it's escaping as gas anyway, and it's the farthest gas ever detected anywhere in our solar system. So what's warm enough out in that much cold and darkness to melt ice that shouldn't melt at all? Its name is Makemake, the fourth largest world beyond Neptune, and until James Webb pointed at it in 2025, nobody thought it had any activity at all. Quick reason for the name, because it trips people up. Makemake isn't a typo or a nickname. It's named after the creator god of the Rapa Nui people of Easter Island. The astronomers who found it in 2005 spotted it just days after Easter, and the name stuck. Okay, so here's the thing about Makemake that makes this whole story strange. It's not like Pluto. Pluto's the one we know. We've got a spacecraft flyby, close-up photos, a thick little atmosphere that's been studied for decades. Makemake doesn't have any of that. It's just a ball of ice, about 890 miles across, a little under the width of Texas, if that helps, sitting way out past Neptune's orbit, quietly taking 307 years to do one lap around the sun. It's basically the quiet cousin nobody paid attention to. But it does have one thing going for it that sets it apart, even from Pluto and Eris. It's soaked in methane ice, like genuinely soaked. Planetary scientist Will Grundy has looked at Makemake's spectrum and basically said, and I love this quote, "Oh my goodness, that thing is methane everywhere. More methane than Pluto has, more than Eris, more than Neptune's big moon Triton. Makemake just wins that contest outright. And that methane is also why it's so bright. It reflects about 80% of the sunlight that hits it, which is close to what fresh snow does. Over long stretches of time, radiation chews that methane apart, strips off hydrogen atoms, and builds up these darker organic molecules that turn the surface a deep orange. The same basic chemistry that colors Pluto. So put that all together and Makemake should be simple, honestly. A frozen, reflective orange snowball, getting slowly irradiated, just sitting there in the dark, minding its own business. That was basically the assumption going in. But if Makemake is just sitting there in deep freeze, why would JWST expect to see anything unusual at all? It didn't. That's kind of the whole point. This isn't a case of scientists confirmed what they already suspected. Nobody was expecting this. Here's how it started unraveling. When JWST looked at Makemake's methane ice, researchers measured something called the deuterium-to-hydrogen ratio. Think of it as a chemical fingerprint that can tell you whether ice has ever been heated up at some point in its past. And when they checked Makemake's ratio, it matched Eris's. Which is a big deal because Eris is a world scientists already suspect might be hiding a subsurface ocean, maybe even some cryovolcanic activity. So if Makemake's chemistry is telling the same story as Eris's, that's clue number one that actual heat, not just sunlight, real internal heat, has touched this ice at some point. Then, clue number two, a warm spot. An actual localized patch on Makemake's surface that's measurably warmer than everywhere around it. And nobody knows what it is yet. Could be darker material just soaking up more sunlight than its surroundings. Could be something venting up from underneath. Nobody's ruling out a cryovolcano, a volcano that erupts liquid water and methane gas instead of molten rock, which, if you think about it, is a wild thing to say about a world this cold. A warm spot is strange enough on its own, but what did JWST find next that turned this from strange into genuinely unexplainable? And then, in 2025, researcher Sylvia Protopapa and her team found something that, by any model anyone had, just shouldn't be possible. Methane gas. Not ice, gas. Floating freely, right near Makemake. Let's sit with that for a second, because this is the farthest detection of gas anywhere in our entire solar system. At Makemake's distance and temperature, methane has no business existing as anything other than a solid. It should be locked into a rigid crystal structure, frozen, motionless, forever. Protopapa herself called it a beautiful surprise, which is a very polite scientist way of saying, this broke our expectations completely. So now line them up. Chemistry that looks like it's been heated, a mysterious warm spot, and gas where there should only ever be ice. Any one of these on its own, interesting, sure, but explainable. All three, together, pointing the same direction? That starts to look a lot less like coincidence and a lot more like evidence. Evidence of a world that's actually doing something, geologically, when nobody expected it to be doing anything at all.
If Makemake really is active, what would even be powering it?
This far from the sun where there's barely any sunlight to begin with. This is where looking at the neighbors actually helps. Take Eris. It's slightly smaller than Pluto by volume, but it's denser, which basically tells you it's got more rock packed inside. And rock carries radioactive elements, uranium, thorium, potassium-40, that generate heat as they slowly decay over billions of years. More rock, more of that slow radioactive heating. And some scientists think that kind of heat could keep driving geological activity long after a world's leftover formation heat should have faded away completely. So if Makemake follows a similar pattern, if it's got enough rock in there generating enough radioactive heat over enough time, that could be exactly what's warming a pocket beneath the ice. Enough to let methane escape as gas. Enough to make an honestly, genuinely active little world, hiding out in one of the coldest, darkest corners of the solar system we know about. Now, to be clear, nobody's confirmed this is actually what's happening on Makemake specifically. The warm spot's composition is still a mystery. The gas detection is recent enough that follow-up observations haven't caught up yet. But the pattern researchers are watching here, chemistry, warmth, and gas, all pointing the same direction, is the exact same pattern that, over on Eris, is already being taken seriously as a sign of a hidden ocean. So if a body this small, this cold, and this far from the sun can still be geologically alive, what does that actually mean for how many dead worlds out there aren't dead at all? And that's really the shift happening here. For decades, this whole trans-Neptunian region was treated like a graveyard. Worlds that froze solid billions of years ago and just stopped. Done. Pluto's flyby back in 2015 already started cracking that assumption open, with the possible ocean the active geology. And now Makemake, smaller, quieter, way less studied, is showing the exact same warning signs. So if an ice ball smaller than Texas, sitting out there with barely any sunlight reaching it at all, can still be leaking gas it has no business leaking, honestly, this stops being a story about Makemake specifically. It becomes a question about how many other frozen worlds out past Neptune aren't actually frozen at all, and what it's going to take to find out which ones. If you're into stories like this, findings that quietly undo what we thought we knew about the solar system, that's basically the whole channel. Subscribe if you want to keep following along as more of these turn up.